and good morning.
Waalaikumsalam, Doktor.
Waalaikumsalam, Doktor.
Good morning. Okay, can see my screen?
Yes, Doktor.
Yes, Doktor.
Okay. Alright. So we continue with the catalytic reaction. Alright. Previously, we have looked at the definition of catalytic reaction or catalysis, and also the function of catalyst in the chemical reaction. Okay, but before that, okay, regarding the material, so if you need any video or any supplement material for the lecture, okay, actually I already record all the video related to the topic. So by end of the class, you can look at your Google Classroom. So saya schedule to post around 11:30. Oh ni so yang last class saya lupa bagi soalan. So yang ni you can answer anytime, due date by midnight. And then for today pun ada soalan, so just a simple question, then you answer a simple answer. You just write the simple answer to as a evidence on your participants in the class. Okay, so untuk material, so I have provided the video for today's lecture and also the video for the tutorial on how to answer the tutorial question. So yang ni you can look at it after the class. So saya schedule the system to post it around 11:30. So you akan dapat notification ni lah. So don't worry about the kalau you nak record the video about the lecture, semua saya dah prepare. Right? Okay, then right, so we continue with the lecture. Okay, so about the chemical catalytic reaction, first, before we go through the derivation of reaction rate tu semua, so we look at the steps that involve in catalytic reaction. So basically, for porous catalyst, okay, porous catalyst will have 7 steps of catalytic reaction. But if the catalyst is non-porous, so yang tu we will look at it later. So first we look at the porous catalyst. So this is the steps of catalytic reaction on the porous catalyst. So if you look at this diagram, so saya buka dia punya pointer dulu. Okay, right. So if you look at this diagram, so imagine this is your catalyst. Okay, let's say sphere's catalyst. The catalyst shape is in sphere's shape. So this is sphere's catalyst and it is porous catalyst. So that's why if you look at ada dia macam pore mouth. So this is the pore mouth. So ada bentuk bulatan ni. So this is the pore mouth because for porous catalyst, it will have pore mouth. Okay. And then why suddenly ada step 1 and 7 je? So where is step 2 until step 5? Okay. First, we define A as the reactant that involved in the reaction, and we have product B. So B as a product, A as a reactant. And for this example, the reaction involved only one reactant, which is A. And actually, for catalytic reaction, usually we just, in this topic, we just consider the reaction that involve one reactant. So if the reaction involve two reactant, it becomes more complicated, especially on the mechanism of reaction and rate law equation. So we just consider for one reactant or single reactant saja for this topic, right? So this is your sphere's catalyst. Okay, step one. Step one actually occur at the external surface of catalyst. Similar for step 7. Therefore, step 2 until step 6 actually occur at the internal surface of catalyst because this is porous catalyst. So it's occur at the interior part of the porous catalyst. So what is the first step? Okay, first we look at the face of the fluid. Okay, so at the outside ataupun at the external side of catalyst, we call it as a bulk fluid phase. So at this point and until here, so this is the bulk fluid phase. So for step 1 occur at the bulk phase. And at this area, starting from this area, this is your external surface of catalyst. So the straight line here, so the linear dotted line, number 2, this is the external surface of catalyst. This area, bulk fluid phase. Okay. This area pula, this is the pore mouth area. From this point to this point, pore mouth. And here is the active site of catalyst ataupun catalytic surface of catalyst. Okay. First, we look at the step 1 at the bulk fluid phase. What happened? So your reactant A, okay, from the bulk fluid, reactant A will diffuse to the external surface of catalyst. So this is the pathway on how reactant A will transfer to the external surface of catalyst. So it will involve mass transfer or external diffusion of reactant A to the external surface of catalyst. Or we can say that the mass transfer of reactant A from bulk fluid to the external surface of catalyst. Okay. And then when the reactant A reach the external surface, so after the mass transfer from bulk fluid to the external surface, so it will reach at the external surface of catalyst, and because the catalyst is porous, therefore the reactant A now will diffuse from the external surface to the internal catalytic surface of catalyst. So diffusion from external surface to the internal surface via pore mouth. So this is the pore mouth. Here, okay, at the outside external surface of catalyst, and on the surface there is a pore mouth. Therefore, reactant A will diffuse to the interior part of the catalyst. Okay, so the process diffusion process. Okay, and then step 3, what happened? Dia dah sampai kat internal area or interior part of the catalyst, and that adsorption will occur. Adsorption of reactant A onto the catalytic surface. Okay. Why adsorption happen? Okay, remember, as I said previously, the reaction will occur on the active side of catalyst. So this is the active side of catalyst, or we can call it as a catalytic surface. So the reactant will absorb onto the active side of catalyst. After the absorption of reactant onto the active side of catalyst, the reaction will occur. So step 4, reaction on the active side of catalyst. What will happen? Reaction of reactant A to produce product B on the active side of catalyst. So reaction only occur on the active side. So kalau non-active side, there is no reaction will occur. So that's why the reactant only absorb on the active side of catalyst, okay, before the reaction occur in step 4. Okay, then after the product B produced, so the product will desorption of product B from the surface of catalyst, ataupun we can say desorption of product B from the active side of catalyst. They detach, but kalau step 3 tadi attachment to the active side. Now after the product produced, detach from the active side via desorption process. Alright, now when we have the product, after the product dissolved from the active side, it will go through the pore mouth again, okay, diffusion of product B from the interior of the catalyst to pore mouth. Dia nak keluar balik. Tadi step 2 masuk, step 6 keluarlah. Okay, so the diffusion of product B from the interior of catalyst to pore mouth. Sebab dia nak pergi balik ke external surface of catalyst. So step 6. And then finally step 7, after the product reach at the external surface of catalyst via pore mouth from the interior side of catalyst. So diffusion of B from external surface to the bulk fluid. So it will going, the product will going back to the bulk area, bulk fluid area. So this is the overall process of catalytic reaction on the porous catalyst. Okay, so similar with the process this diagram, and this diagram actually similar with this one. Okay, sama je. All the process is for porous catalyst. Okay, so this is the details explanation on the steps of catalytic reaction on porous catalyst. So yang in the diagram ni, this is the simplified step. Okay, so the details explanation at this page. Okay, so first, external mass transfer of reactants from the bulk fluid to the external surface of the catalyst pellet. Pore diffusion of the reactant from the pore mouth through the catalyst pores to the immediate vicinity of the internal catalytic surface. So if you look at the explanation, macam it's quite difficult to explain, but you still can use this explanation. Okay, diffusion of A from pore mouth to the internal catalytic surface. Yang ni pun still acceptable. Kalau you buat simple explanation pun still acceptable. Okay, compared to this details explanation. Alright, then step 3, absorption of reactant A onto the active side of catalyst surface. Then step 4, reaction on the surface of the catalyst, reactant A to produce product B. Step 5, desorption of the product from the surface. Step 6, pore diffusion of the product from the interior of the pellet to the pore mouth at the external surface. So dia terbalik daripada step 2 tadi. And then finally, external mass transfer of the products from the external pellet surface to the bulk fluid. Okay, until now, still can follow or not? Boleh follow ke tak untuk ni, this topic, steps in catalytic reaction? Then we continue. Okay. Okay, now we will look at one by one the details, theory, ataupun explanation or principle behind each steps of reaction. So tadi overall steps. Okay, now we look at one by one. First, we look at the diffusion from the bulk to external transport. Ni yang the first one, the first steps tadi, external mass transfer of the reactant from bulk fluid to the external surface of catalyst. Alright, so imagine this is your porous catalyst. Oh, before that saya lupa. This is the step for porous catalyst. But what happened if the reaction is on the non-porous catalyst? Okay, if non-porous catalyst, there is no pore diffusion occur because there is no pore mouth. Bila tak ada pore mouth, of course, there is no diffusion of reactant to the onto the interior surface of catalyst. So for non-porous, there is no pore diffusion. Therefore, step 2 and step 6 will be eliminated. Okay, so there are 5 steps sahaja. If non-porous, for non-porous, reaction only occur at the external surface of catalyst. So no pore diffusion, step 2 and 6 tak ada. So dia apa yang berlaku? Only step 1, step 3, step 4, step 5 and step 7. Meaning that okay, when the reaction occurs at the external surface of catalyst, so step 1 still sama. Step 2 becomes the absorption. So after the reactant reach that at the external surface of catalyst, so the reactant will absorb on the active side at the external surface of catalyst. And then reaction pun will only occur at the active side of the catalyst at the external area. Okay, so beza dia there is no pore diffusion. The reaction only occur at the active side of external surface area of catalyst. Okay. Now we look at the step 1, okay, diffusion of reactant from bulk fluid to the external surface. So this is your catalyst and this is the bulk fluid. So the other area is bulk fluid. So in between the bulk fluid and external surface of catalyst ni, there is a boundary layer. Okay, boundary layer with thickness of delta. So delta here is the thickness of boundary layer. So the boundary between the bulk fluid and the external surface of catalyst. Okay, so the concentration of reactant at the bulk fluid as CAB, and the concentration at the surface of catalyst, we write it as CAS. So there is a temperature gradient at the bulk, in between the bulk fluid and at the external surface of catalyst. So the temperature gradient is depends on the velocity of bulk fluid. Okay, usually the temperature gradient is very small. Sekejap. Hello kelas Mac. Tengah lecture. Bye. Okay. Right. So assume diffusion of reactant A to the external surface of catalyst is the slowest step. Why we need to assume the diffusion step is the slowest step? Okay, this phenomena is depends on the velocity of the bulk fluid. If the velocity of the bulk fluid very low, so that's why they tulis kat sini low velocity. Okay, kita just focus on this image first, this diagram first, and then after that baru kita look at the second diagram. So from this diagram, for low velocity of fluid, bulk fluid, the diffusion of reactant A to the external surface is very slow. That's why we consider the diffusion of A to the external surface is the slowest step. So reactant A at a bulk concentration CAB must travel through the boundary layer with thickness of delta to the external surface of catalyst pellet with concentration CAS. So yang ni the temperature gradient. So how the reactant A will transfer to the external surface tadi? Ni yang ayat ni, must travel to the through the boundary layer. So the reactant A from here at the bulk fluid, so yang anak panah yang saya ingat ni maksudnya the mass transfer of reactant A to the external surface of catalyst. So this is the thickness that the reactant A will go through in order to reach the external surface of catalyst. So if you look at the thickness of this boundary layer, it's quite thick. Okay, so why the thickness of this boundary layer ni very thick? Because of low velocity of bulk fluid. So at low velocities of fluid over the pellet, maksudnya at low velocity of bulk fluid over the catalyst pellet, the boundary layer across which reactant A and product B must diffuse is thick, resulting in a small mass transfer coefficient. Okay, so bila when the boundary layer thickness is thick, therefore the transportation of reactant A from bulk fluid to the external surface to very slow. That's why bila dia very slow, mass transfer coefficient dia pun very small. Okay, mass transfer of reactant to the external surface tu, where the coefficient is very small. mass transfer across the boundary layer is slow, and therefore it will limit the rate of overall reaction. So when this happen, meaning that the reaction to produce product is faster than mass transfer. Okay, sebab mass transfer from bulk fluid to the external surface ni very slow, but at the same time reaction of the product reaction of the reactant to produce the product at the active catalytic surface at the external ni, okay, dekat external ni ada juga active surface of catalyst. Of course, the reaction to produce product will occur. But due to the mass transfer of reactant is very slow, therefore reaction is more faster than the mass transfer of reactant. Reaction to produce product more faster than the mass transfer of reactant untuk sampai ke external surface. So that's why the mass transfer of reactant will limit the rate of overall reaction. So apa maksudnya? Maksudnya your reaction rate equation. So usually you tengok in reaction engineering 1, rate reaction negative RA equal to KCA. So now dia punya rate law equation, so negative RA is equal to the mass transfer reaction, not the rate reaction to produce the product, but it's equal to the mass transfer. So macam mana berlaku? So after this I will show you the equation. Okay, this is happen when the bulk fluid velocity is low. However, if the bulk fluid velocity is high, okay, so dia jadi terbalik lah. When the velocity of bulk fluid is high, the boundary layer across which A and B must diffuse is thin. So when the high velocity fluid used, the boundary layer become thin. Okay, dia tadi thick boundary layer. So you compare the delta thickness. So this one is very thick. Yang ni dah jadi thin layer. So the area ataupun the time required for the reactant A to travel from bulk fluid to the external surface of catalyst jadi more faster lah. So the travel time required lagi small, and then the mass transfer ataupun the transportation of reactant A much faster when the high velocity when the bulk fluid velocity is high, because the boundary layer thickness A dah jadi thin layer. So dia cepat sampailah at the external surface. Therefore, the mass transfer no longer limit the reaction. Kalau tadi low velocity mass transfer limit the overall reaction, but now because the boundary layer ni become thin boundary layer, so the mass transfer no longer limits the overall reaction. So now what will happen? Bila dah banyak berkumpulnya all the reactant at the external surface, okay, external surface and also the active site, therefore mass transfer faster than the reaction to produce product. So reaction becomes slower because there is more reactant compared to the active site required to produce the product. This is because the mass transfer faster than the reaction. So now bila mass transfer no longer limit the reaction, so dia dah jadi rate of overall reaction is controlled or limit by the rate reaction to produce the product. Itu adalah the principles of diffusion of reactant from bulk fluid to the external surface of catalyst. So we just focus on the reaction at the external surface of catalyst. So kita tak consider lagi the diffusion through the pore mouth tu lagi. So we just consider the diffusion from the bulk fluid to the external surface, and at the same time the reaction occur at the external surface area. Okay. So external resistance also decrease as the particle size is decreased. External resistance is sama lah, mass transfer coefficient lah. The same thing, mass transfer. So mass transfer resistance decrease as the particle size is decreased. So particle size of catalyst. So if we use the catalyst with small particle size, so that we can reduce the external mass transfer. Then as the fluid velocity increase and the particle diameter decrease, mass transfer coefficient increase until plateau. So if we use high velocity, if we use small diameter of catalyst, we can increase the fluid velocity and at the same time increase the mass transfer coefficient for the diffusion of reactant to the external surface of catalyst. So until plateau ni, until dia macam equilibrium lah, until reach equilibrium. Therefore at this situation the temperature gradient equal to 0. Di mana concentration of reactant at the bulk fluid will be equivalent to the concentration of reactant at the surface of catalyst. So when the plateau is steady state, when it reach a steady state, okay. But it depends on the fluid velocity and also the diameter of catalyst that we use in the reaction. Okay, so itu about the process, about how the mass transfer occur from bulk fluid to the external surface. And now we want to relate it with the rate equation. So at steady state, rate of transport to surface, rate of transport ni rate of mass transfer lah. Okay, mass transfer rate equal to the rate of reaction at the surface. Reaction rate yang you biasa buat, negative RA equal to KCA. So the reaction to produce the product. So mass transfer equal to the rate of reaction. So this is what happened at the steady state. Right, for first order reaction, okay, so even though at steady state tadi at the plateau we say that the concentration almost similar, but we still need to but the concentration at bulk fluid before, this is the concentration before the mass transfer, before the transportation of reactant occur. So the initial concentration of reactant at the bulk fluid. That's why we include it into the equation. So that we still need to consider the temperature gradient. Okay. So for first order reaction, so usually catalytic reaction we just consider it is for first order. So kalau ada second order tu rare case lah, but usually it is first order reaction. So that's why CAB power of 1, CAS power of 1. Okay, for both sides. So this is the rate of transport ataupun the rate of mass transfer. That's why ada mass transfer coefficient here. Mass transfer rate, we need to multiply with the surface area of catalyst. 4 pi r square is the surface area of catalyst. Okay. 10. Okay. So this is the rate of mass transfer and it's equal to the rate of reaction. Rate of reaction actually 4 pi r square multiply with r. This r, this is the rate of catalytic reaction which is equal to this one. Okay, so if we simplify the equation, actually 4 pi r square KMA CAB minus CAS also equal to 4 pi r square KCAS. So kenapa ada double force trophy here? Double force trophy ni yang ni you dah we have learned it in reaction engineering 1. This is the rate equation for catalytic reaction. So dia kena ada double force trophy to show that this is the rate constant for catalytic reaction. Similar with the symbol of rate reaction. Rate reaction with double force trophy. This is the rate reaction for catalytic reaction. So this is you have learned it in reaction engineering 1, chapter 1. Okay, ada definition of for each rate reaction and the unit of rate reaction. Okay, kalau tak ingat, tengok balik dalam nota reaction engineering 1 chapter 1. Okay, so this equation actually similar with this one. Okay, so sebab yang ni saya nak tunjuk this rate of transport ataupun rate of mass transfer actually equal to rate of reaction, and this rate of reaction equal to this equation. So kalau yang tak tulis yang dekat in the middle equation ni, you want to remove it pun also can, tak ada masalah. Okay, and then 4 pi r square, because both sides we multiply with the surface area, so we can cancel out 4 pi r square. 4 pi r square can cancel out. Therefore, the final equation is KMA CAB minus CAS equal to KCAS. Right. And then rearrange for CAS and it's equal to, okay, after we rearrange for CAS, so this is the equation that you will get. Why we need to rearrange for CAS? Okay, because the overall rate equation ataupun rate law, okay, yang ni, this is the rate law equation. Okay, so this is the rate law equation. Rate law equation, we want to write it in terms of concentration of reactant at the bulk fluid. That's why we want to eliminate term CAS. So, rearrange for CAS. So, dapat CAS, this is the equation. Insert back into the rate law equation, rate reaction equation. Okay, this equation, okay, insert back to this ni CAS ni, replace it with this equation, and then dapatlah overall rate law R equal to KCAB divide with the denominator 1 plus K over KMA. Or you can rearrange the denominator. So kalau macam ni 1 plus K over KMA. You also can rearrange it as a kalau you buat ni 1 ni as a KMA plus K over KMA pun boleh. And then this KMA you naikkan ke bahagian numerator. So it will becomes yang ni you kena tulis lah baru you nampak. So dia akan jadi R equal to KMA K CAB over KMA plus K. So yang tu the original equation actually yang tu. Okay, bila you rearrange ni and then bila you simplify kan baru you dapat denominator as 1 plus K over KMA. And this term, this K equal to effective K, effective rate constant. So detail derivation in tutorial. So nanti ada tutorial question. Saya akan tunjuk tutorial question yang saya dah bagi dalam video supplement material tu. Okay. Okay, then based on this equation juga, if the reaction is reaction limited, what will happen to the overall rate equation? So saya delete dulu untuk yang ni, nak conteng yang baru. Discard. Okay, tunjuk semula. Right. Okay, what will happen to the overall rate law equation if the reaction is reaction limited? Okay, so we need to look at the rate constant and mass transfer coefficient. If the reaction is reaction limited, maksudnya mass transfer coefficient much larger than rate coefficient ataupun K. KMA much larger than K. This is when the reaction is reaction limited. So KMA much larger than this K. So if you look at the denominator, when the KMA is much larger than K, so of course lah small value divide with large value, the answer will become infinity. Infinity ke almost to zero. Kena check balik dekat calculator. So when this happen, so this term will be negligible. Okay, kecil bagi besar almost zero. 1 plus ni almost zero. So the reaction is reaction limited. So bila this term negligible because of this KMA value is much larger, therefore overall rate law equation becomes R equal to KCAB. Okay, itu untuk case reaction limited. So reaction limited, Km much larger than K. Okay. Itu untuk reaction limited. But what happen when the mass transfer limited? Kalau mass transfer limited, of course, K pula yang much larger than Km. So when mass transfer limited, what happened to the overall rate law equation? So before you solve the denominator, you need to rearrange, jadikan yang equation asal balik. So when this happen, so KMA you bawa naik atas, therefore the denominator becomes KMA plus K. So K larger, we look at the denominator. So K larger than Km, therefore we can, the Km term will be negligible. Km term at the denominator will be negligible. Okay, and then yang tinggal, so yang ni kita dah bawa ni atas. Kena rearrange balik, yang ni bawa naik atas. Okay, bawa ni atas. So this K much larger. So term Km, so sepatutnya dia akan jadi Km dekat sini, Km plus K. So this Km term yang akan muncul dekat sini will be negligible. And then dekat atas ni pun ada Km. So, okay, saya cancelkan yang ni. So yang ni pun jadi Km. Okay, yang ni bila mass transfer limited. So Km plus K, this K much larger, we can cancel out. Then this K dengan this K can cancel out later. So the overall rate equation becomes R equal to Km CAB bila mass transfer limited. So cara paling senang nak ingat, if the reaction limited, R equal to K double apostrophe CAB. Kalau mass transfer limited, R equal to Km CAB. Tapi macam mana you nak derive? Yang macam tadilah, you kena rearrange the denominator. Okay? Okay, now we look at the definition of mass transfer coefficient. Or you want bio break first? Kita break kejap lah dulu for 5 minutes and then after that we continue with mass transfer coefficient and then saya tunjuk soalan, contoh soalan. Right, kita break sampai pukul 11 kejap.
Okay, thank you, Doktor.
Okay, kita sambung lagi berapa slide? Lagi 1, 2, 3, 4, 5 slide. Okay, hopefully by 11:30 kita dah habis. Alright. Okay, so mass transfer coefficient. So Km, how to calculate Km and where this Km comes from. Okay, so actually you have learned it in transport phenomena. Okay, consider the mass transfer correlation for gas. So from mass transfer flux, definition of mass transfer flux that you have learned in transport phenomena. J ni mass transfer flux equal to Km mass transfer coefficient multiply with Ca1 minus Ca2. So this is the concentration gradient. So it's similar with the mass transfer from bulk fluid to the external surface of catalyst tadi. So mass transfer flux equal to rate of mass transfer and it's equal to Kma. Ca1 ni equal to Cab and Ca2 equal to Cas. So tak ada beza. Mass transfer flux actually the equation is similar with the mass transfer of reactant from bulk fluid to the external surface of catalyst. Okay, mass transfer coefficient is defined through Sherwood number. So this is the Sherwood number equation. SH Sherwood number equal to mass transfer coefficient multiply with L. What is L? Okay. It's not the length of reactor, bukan length of reactor, but the length of catalyst. But bukannya kalau diameter, kalau spheres or cylinder, you tak measure the length of catalyst itself, but length here is the characteristic length. So bukan dia punya length of spheres tu, not the length of cylinder shape of catalyst. No, is this the characteristic length? Okay, and then we divide it with the diffusivity factor. Okay, capital D here is diffusivity ataupun diffusion factor. Alright. Okay, when you have this equation, now we look at the shape of catalyst. So the Sherwood number will depends on the shape of catalyst. Basically, there are three shapes of catalyst that we will consider. Okay, the first one, flow over a flat plate. So this is when the bulk fluid is flow over a flat plate shape of catalyst. Flat plate ni similar with thin film, a thin layer of catalyst. Kalau dalam bentuk flat sheet of catalyst, and then we also need to look at the flow, either it is laminar or turbulent. Okay, for laminar flow over a flat plate of catalyst, the Sherwood number equal to this equation. So you need the Reynolds number and Smith number. Okay, similar for turbulent flow. So this is the equation. But we rarely use these two equations because usually we use the catalyst that have sphere shape or cylindrical or tubular shape of catalyst. Jarang lah guna flat plate catalyst. Flat plate catalyst ni if we use metal catalyst dalam bentuk metal plate, yes, we will use the flow over flat plate. So it depends on the catalyst that we use. Alright, then next, flow through a tube. Okay, flow through a tube ni, this is the cylindrical shape of catalyst, because the cylindrical shape of catalyst tu dia similar as a tube. Okay, then if flow through a tube or cylinder and the flow is laminar flow, the Sherwood number automatically equal to 8/3. But for turbulent flow, you need to calculate the Sherwood number by using this equation. And finally, flow over a sphere. Okay, flow over a sphere ni, yang ni shape yang biasa kita guna, sphere catalyst. The Sherwood number equal to this equation. But if the reaction occur in a stagnant flow fluid, okay, the flow of the fluid is very slow, we call it as a stagnant fluid, the Sherwood number equal to 2. So just insert this value into the Sherwood number equation. Okay, and then what happened to the characteristic length tadi? So kalau cylindrical shape or sphere shape, the characteristic length ni will becomes the diameter of catalyst. So diameter of spheres or diameter of the cylinder. Okay, then we look at the kita pergi yang ni dululah. After this kita tengok soalan yang related to the external mass transfer. Because internal diffusion ni we just look at the principle sahaja. Right, so we are done with step 1 tadi, okay, mass transfer. Now we look at the step 2, internal diffusion or pore diffusion from the external surface to the interior surface of catalyst via pore mouth. Okay, so how the pore diffusion occur? Reactant A diffuse from external surface of catalyst into the pellet interior where the concentration is Ca. So tadi dekat at the external surface, the concentration is CAS. Bila diffusion happen, when the diffusion occur, and then the reactant A from the external surface will go through the interior surface of catalyst, the concentration becomes Ca. So there is a temperature gradient here, but usually the temperature gradient is the concentration gradient. The concentration gradient will be small and nearly to 0. Okay. As reactant A diffuses into pellet interior, it reacts with catalyst deposited on the side of pore wall. So the reaction will occur on the active side of catalyst at the interior. Okay, now we look at the effect of diameter of catalyst, okay, ataupun size of catalyst. Okay, for large pellet, so for large size of catalyst, okay, for large pellet, longer time required for the reactant A to diffuse into interior of catalyst compared to the time it takes for the reaction to occur. Okay, kenapa? So because the size of catalyst is bigger. So kalau diameter of the catalyst is bigger, of course the diffusion ataupun the transportation of reactant from the external surface tu, dia nak masuk ke dalam through to the interior part of the catalyst, it will take time because the path that the reactant need to go through to is longer. Okay, disebabkan oleh the size or the diameter of catalyst itself. Thus, the reactant is only consumed near the exterior surface of the pellet. So maksudnya reaction banyak berlaku at the external surface compared to the reaction at the interior, because the time required for the reactant A to reach the active site at the interior tu longer compared to the reaction that occur at the external surface. So when this happen, we call it as internal diffusion is limiting the overall reaction. Okay, if we use the large size of catalyst. But if we use small diameter of catalyst or small size of catalyst pellet, of course lah, it will take shorter time for the reactant A to diffuse into the interior surface of catalyst. Therefore, internal diffusion no longer limiting the reaction. Sebab most of the reactant A already diffuse onto the interior side of catalyst. Okay. So boleh faham tak internal diffusion ni? When it is diffusion limiting or when it is reaction limiting. Boleh follow ke tak? If you have any question, you can ask during the bila saya explain, you can ask. Okay, if you don't understand how the process occur. Alright. So if you don't have any question, we can proceed. Okay. Now, so K, the rate coefficient, is an overall rate constant, and it is a function of particle size. So function of diameter lah. Overall rate constant increase as the pellet diameter decrease. Okay, because in this case, when the pellet size is small, the rate constant increase. Therefore, what will limiting the reaction now is the pore diffusion no longer limiting the reaction. So reaction yang limiting the overall reaction. Sebab pore diffusion berlaku, pore diffusion is much faster than the reaction to produce the product. So overall rate constant increase as the pellet diameter decrease, and the rate of pore diffusion equal to this equation. So this is the rate of pore diffusion, rate reaction when the pore diffusion is larger than rate of reaction. So maksud dia. So this is the rate reaction. Rate reaction equal to, so sama juga dengan yang tadi, R equal to KCAS, but we multiply it with mu. Mu ni effectivity. So effectivity value ni actually to calculate this effectivity quite complicated sebab dia banyak equation. And basically for pore diffusion, kita tak consider to calculate the rate reaction, the overall reaction. You just need to know the principle how the internal diffusion occurs sahaja. So yang equation ni kita tak akan guna untuk pore diffusion. So you just need to know how the internal diffusion occur and what will affect the internal diffusion and reaction at the interior side. Okay, why the rate of pore diffusion is quite complicated? Okay, so this is the problem. Okay, so when we deal with the pore diffusion, we need to consider the concentration gradient at different at different position. So this is the pore mouth. Okay, so at this point, and also at this point, it will have temperature gradient. So if you look at this curve, so you can see the change in temperature gradient. So when the mass transfer occur from the external surface to the interior surface, so we need to consider the the concentration change along the pore mouth. Okay, problem in pore diffusion is the rate is a function of position x within the pellet. So position ni we say it as x lah, position x within the pellet. So average concentration is required in mass balance. Thus the concentration profile will be solved in terms of concentration at the pellet surface. So bila the reaction involve internal diffusion, and because the rate and the concentration is depends on the position where the reaction occur, and it depends on the length of pore mouth, so we need to do the shell balance. Shell balance ni yang becomes complicated because it will involve the shell balance on the mass transfer. Okay, net flux in at x position minus net flux out at the x plus dx position, and that is equal to rate of reaction on wall between x and x dx. And actually this equation, if we replace it with the equation yang ada K and CA, CAS tu semua, you need to solve the integration and then ada differentiation, so it becomes complex. Then we are not able to solve it by using manual calculation. You kena buat modeling, okay, baru boleh solve. That's why kita hanya consider the theoretical part, the principle on how the internal diffusion occur and what will affect the pore diffusion. So kita tak consider the calculation part. Okay, so kita stop sampai situ. Okay, before we end the class, we look at the question. So question ni pun ada saya bagi dalam supporting material. Okay, so yang ni on how to derive the rate law equation. Okay, let's say yang saya bagi tu jawapan dia, the answer for both question actually similar. Jawapan dia sama. Cuma term dia berbeza, diameter or radius. Tu je beza dia. Right. So let's take a look at this equation. Ni yang related to external mass transfer tadi. Okay. A reactant of bulk concentration Ca0 reacts on the external surface of catalyst spheres of radius r in a slurry reactor. So given the initial concentration at bulk fluid Ca0, and then the diameter of catalyst, spheres catalyst, diameter dia bagi radius. So in this case dia bagi radius r in a slurry reactor. Reaction is first order reaction, first order surface reaction rate coefficient K, and diffusivity of A is dA. So diffusivity must be in capital D. Determine the effective rate coefficient in terms of these quantities, assuming that stirring is sufficiently slow that the fluid around particle is stagnant. So dia dah bagi semua clue dekat sini. Assuming that the stirring is sufficiently slow, fluid around particle is stagnant. So we know from this clue, we know what is the Sherwood number value, which is 2. So kita tengok balik Sherwood number, kalau stagnant fluid and then the The catalyst is sphere's catalyst, so automatically Sherwood number equal to 2. Right. How to solve the question? So yang ni actually saya tukarkan what I wrote in the video, saya export dia jadi dalam bentuk PDF. So yang ni ada dalam video. Okay, how to solve the question? Rate reaction on the external surface of catalyst. And then given it is non-porous surface, no accumulation on the surface, rate of transport equal to the rate of reaction at the surface. So maksudnya the external surface lah. Rate of transport, okay, define satu-satu. What is the rate of transport? So surface area multiply with KMA, CAB minus CAL. So semua ni ada dalam nota. Rate of surface reaction, surface area multiply with the rate reaction. Okay, and then saya dah tunjuk definition. Alright, so example untuk soalan tadi. First order reaction irreversible on spherical catalyst. Okay, at steady state, rate of transport equal to rate reaction on the surface. For spherical, surface area equal to 4 pi r square. Okay, so therefore, okay, ganti masuk, rearrange the equation, cancel out. Macam yang tadilah yang ni, yang detail derivation yang saya cakap dalam nota tadi. So rearrange, okay, dapat yang ni. So yang ni yang saya tunjuk tadi, macam mana nak rearrange for KM tadi. Okay, okay, now we solve the question. So you have the overall rate law equation as this equation, to tak kisahlah either one. Okay, then define what is the mass transfer coefficient equation from the Sherwood number equation. So in this case, because the catalyst is spheres, characteristic length dia becomes the diameter of spheres. And then given in the question tadi, dia bagi radius. So diameter equal to 2r. Okay, then replace lah the diameter in terms of radius. Dapat this equation. Ganti masuk dalam rate law equation. So if stagnant flow, Sherwood number equal to 2. So finally you will get this equation as the overall rate reaction. So senang je this part. Okay. So kalau you tengok, I think I give the answer. So you can replace the Sherwood number. Oh, this one saya tak bagi overall answer. So you kena rearrange lah. And then for equation 1 pun sama je dia punya derivation on how to derive it. So kalau tak nak confuse diameter, jangan buat capital D. Okay. So untuk question 1 soalan dia sebab sama, so this is the answer. Question 2 pun you should get the same answer. Or question 2 ni, because in terms of R, you can replace D as 2R and then cancel out 2, dapatlah R over dA. Jawapan dia sama macam ni untuk yang ni. Okay, actually these two equation sama. Right? So yang tu you can look at the video nanti and try to solve this question. Try to buat derivation. You buat balik derivation tu, baru you nampak, baru boleh faham. Okay, think that's all for today. Okay. Any question? Ada soalan? Ada yang Kak Nanya tak faham? Tak ada?
So far tak ada, Doktor.
Alright. Okay. So I think that's all for today. So we can stop the lecture session and we meet again on Selasa on Tuesday. Right? So nanti untuk Google Meet link, okay, actually we will use the same Google Meet link untuk Tuesday, Google Meet link yang sama on last Tuesday. For next Friday pun Google Meet yang link yang sama dengan hari ni. So nanti I will update dekat WhatsApp group tu. You will you tengok dekat bahagian description. So later saya akan update bahagian description dekat our WhatsApp group. So next time kalau saya terlupa post dekat classroom, you just look at the description dekat WhatsApp group. So itu adalah link dia. So kita guna link yang sama for the whole semester. So in case saya lupa lupa post dekat Google Classroom. Right? Okay, thank you everyone. See you all next Tuesday. Thanks for your time.
Thank you so much, Doktor. Thank you, Doktor.
Thank you, Doktor.